clock's ticking. Okay, so we're going to learn 5 minutes before we go to lunch here. Okay. Okay, so we're going to solve trig equations here for 2 days. Monday, Wednesday, it's all the same stuff, just different methods for how to solve. This is algebra with trig functions in it. It's fairly common sense, not a world-ending something new and different. However, the good news is those lovely identities we just did, we get to use them again. They are still with us. Okay, they are going to ask you to solve for x here. My question to you is, what does x represent in this problem? An angle. X is an angle. So when you solve trig equations, your answers are going to be angles. When you get done, I have no idea because I don't know what the first question is. No, that's not. I am not teaching this in order, and I'm not teaching you inverse trig functions first. I'm teaching you second, so the journal is going to be down a ways. Okay, they're going to tell you whether you are solving in degrees or radians. So in this case, they're going to give you an interval, and it says from 0 to 2 pi. So that tells you you're solving in radians. Now, why would they limit you from 0 to 2 pi? Why can't you just get every possible answer? Yeah. If your answers are angles, if your answer is an angle at 60 degrees, and you don't limit it, then you have to go around the circle again and give me the next answer that ends at 60 degrees, and you got to go around the circle again and give me the next answer. You got to keep giving all the coterminal angles that end at that same spot, which would be an infinite number. So you're not going to name them all. So they're going to limit you to going around the circle once.
Do we need that yellow sheet still?
You will need your yellow sheet off and on, yes. It's still going to play. Okay, so I want to solve this. It's quadratic. Something squared, something to the first power constant. How do you typically solve quadratic equations? Well, you factor them. It's already equal to 0, so you just need to factor it back into pieces. Like we factored with our identities when you were verifying them. That whole verifying chapter was setting you up to solve these. So it would have to be a 2 sine of x and a 1 side of x. And then I need factors of 3, which have to be 3 and 1. Okay.
1 in the second one.
You want 1 back here? No. That'll give you 3 and 2, but they'd have to have the same sign to make 5. So you want, I guarantee the rest of you want to go the other way, 1 and 3? Okay. So what can I, minus plus. And so therefore, what do you normally do after you get factors? You set them equal to 0. So we have factors, so we set them equal to 0. It's not like this is something unknown. It's just got a trig function in it. And then when you solve each one, you're going to solve for sine here. So I'm going to end up doing what? Yeah. I'm going to add 1 over, divide by 2. I'm going to end up with sine equals a half. That's nice. And over here, I'm going to end up with sine equals negative 3. Now, here's the new part. That was pretty much algebra. Now you have to come up with what angles does sine equal 1/2 at?
30.
We're in radians, so instead of 30 degrees, you're going to tell me 5 or 6, yes. How are you going to know what quadrants to put it in?
Sine's positive.
Sine's positive. So you're going to put it, use all-star trig class, you're going to put it in the positive quadrants. And 5 or 6 is your reference angle. Okay, do you remember how to name angles like that? From here to there, it's
1 or pi.
it'll be pi over 6, and then if you start at 0 and go over to here, how do you do second quadrant? Yeah, because you go, this is pi or 6/6. I'm backing up 1/6, so I would get 5/6. Okay, and so there's the 2 answers that come from that. Are you done?
No.
No. You have to go do the other one. Sine has to equal negative 3.
Cosine something, right?
Where's sine equal 3 at?
Nowhere.
Well, why'd you say nowhere?
No,
Bingo! Yes. You remember the lovely chart with the ones and the negative ones? Sine can only have values between 1 and -1.
What you guess, right?
So if you get a value, sine is equal to a number outside 1 and -1, that's not possible. You just cross that one out and go, that one's not valid to it. So in that case then, these are our only two answers.
But if that did work, you'd have like
Yeah, you could get like 4 answers, yeah. Yeah. You
is the what sign's gonna equal? Is it generally gonna be like a half, 3 times, or square root 3 over 2?
That's a great question. If they're having you work the problem in radians, it's going to come out the special angle value. If they're having it you're solving it in degrees, then we'll be able to go to our calculators to get other angles that we aren't special, so those won't necessarily. If you're in radians, it's got to be special. So that's kind of all right, yes, head off to lunch. I'm just going to pop it out. Uh-oh. Nothing is working. There we go. We're cooking. Okay. The clock is ticking. We are back from lunch here. Ready to solve some more equations. Now that one was probably too easy and I've insulted your intelligence.
No, it
I'm
was
not
good.
insulted.
That's as hard as you should get.
Well, we need to put a little pizzazz in our lives here. So perhaps we should try one where the trig functions are different. That last one was all sines. That was nice. You know, it was all quadratic to start with. This one has a little more interest to it since it's got a secant and a cosine in it. And I still do want to solve it for right now doing radians. So, now, this morning they asked this question. Why am I putting a bracket on one end and a parenthesis on the other?
Because it can be 0, but it can't be 2 pi.
Yeah. Can be. Why wouldn't they want you to do both 0 and 2 pi? Yeah, they're the same angle. So 0 is the same thing as 2 pi. Why do both? So that's why there's a parenthesis on the 2 pi end. Okay, how am I going to solve this? Even if
Making our secant 1 over cosine.
Matt thinks we're going to change secant to 1 over cosine.
I agree with that.
Yeah, you can't solve it like this. There's nothing you can do to it, even if we set it equal to 0. It's not solvable. You need to get it all in the same trig function. So yes, that's where your fundamental identities are going to come back to haunt you. Today, you're only going to see the fundamentals. Now, next class, we'll be throwing doubles and half angles in there as well. But today, it's the fundamentals will get you out of most of your problems. So, now, from here on out, it's algebra. I now have a fraction. I want to solve with a fraction. What do I do about it? Yeah. How do you get rid of any fraction if you don't want to work with it? You multiply by the denominator, so you get rid of it. So I'm going to take this whole thing times a cosine. And of course, the key thing is, just like with normal algebra, you got to take it times every term, whether it's a fraction or not. So what's the left side going to become? Cosine times 1 over cosine. The cosines will cancel, and you'll be left with 1. But you also have to take it times the right side, which is going to give you what? 2 cosine squared, because cosine times cosine is cosine squared, and then plus cosine. Okay, now you're all in cosines, no fractions, and it looks pretty quadratic to me. So I should subtract 1.
Can you not just pull out the cosine?
You can't factor and solve unless it's equal to 0. That's not. You won't get a correct answer. What are you going to do if you factor it out? You're going to set them both equal to 1. That doesn't work. If you remember the good old zero product property, back from those, you can only work with things that are set equal to 0. So you have to get it equal to 0. And you still always want your squared term positive. Makes your life a lot easier. So if I subtract the 1 over, it'll be on the end. Okay, what do we try? Yeah, might as well try to factor it. And so, yeah, it does work. It'd have to be 2 cosine and 1 cosine if it's going to work. And it's got to be 1 and 1. Signs have got to be opposite, so negative, positive. Okay. Looks pretty nice. I am okay. If you can look at that and set it equal to 0 and solve it in your head, that's perfectly fine. I would hazard to guess that you can do this one. Yeah, because I'm going to add 1 and divide by 2, so cosine, of theta equals a half. And the other one's going to come out to be cosine of theta equals negative 1. Okay, first question I would ask myself, are those both possible values for cosine? Can it equal those numbers? Yeah, because it can't be outside 1 and negative 1. So those are both good answers. Since we're in radians, we're going, yep, those are special angle values. That's good news. If you're in radians and you don't get special angle values, something's wrong. So where can our answers be here if cosine's a positive half?
1/3.
Okay, it could be in the first quadrant or the,
Third.
which one, third or fourth for cosine? I'll start trading class. So yeah, fourth quadrant. Okay, where does cosine equal a half?
Third. 1/3. 1/5.
Pi over 3 is our reference angle. This is the reason I made you do the flashcards. So the first quadrant angle is not too tough. You know your answer's pi over 3. But what is it when I go clear around to the fourth quadrant? Start here and go all the way around. That would be 2 pi or 6/3. Backing up 1/3 would give you 5/3. Okay, now the other one, what should you instantly think anytime it's equal to a 1, a 0, or a 0? You're sitting on you're sitting on one of the quadrant lines. Yeah, it's got to be on the axis unless it's tangent. Tangent equals 1 at pi over 4. But anything else, if you got a 1 or a 0, you go, oh, I'm sitting on a quadrant line. The question is, which one? Well, cosine is positive 1 at 0. So therefore, it's negative 1 where? It has to be negative 1 over on the other side. And in radians, that angle is what? Pi, not 180. So that would give us an answer of pi, and we would have, in this case, 3 solutions. However, occasionally there are 2 situations where you'll have to check your answers, and this is one of them. Anybody remember what extra step you had to do when you were solving equations that had, we had variables in the denominator? What did you always have to check for? You couldn't divide by 0. We called them excluded values. We excluded the ones that were going to make it divide by 0. Okay, so here, you could look at it with x's. It was 0 and 3. We're going to make the denominator equal 0, so we excluded them as answers. In this case, we had a fraction back up here at 1 over cosine. So we can't be dividing by 0. So you can't have any angles that make cosine equal 0. Okay, first of all, where does everything equal 0 at, as far as trig functions go? Where are all the zeros in your special angle table? They're either at the 0 or at the 90 or pi over 2. They're on the quadrant lines. So first of all, the only answers you even need to think about worrying about are the ones that came out on quadrant lines. They didn't come out on quadrant lines. It's going to be fine. So we would have to worry about that cosine of pi, but we know cosine is 0 at the bottom of the table, which is 90 or pi over 2. So you'd actually only, in the case of cosine, you'd be worrying about anything that had a 2 on the bottom. Since we didn't have any like that, and we already know pi is where it equals negative 1, those are all good. But you do have to stop and ask yourself. Occasionally you will throw one out. It's not super common, but once in a while you'll get an answer that doesn't check. So you do need to check for excluded values if you have fractions in your problem. Oh, you're right. I'm about to, darn, I wanted to say my last few words, but okay, we'll pause a second. Thanks.